6.1. Sketch below shows the pyramid on the square base. It's a pyramid on a square base. The length of the side of the base is 10 centimeters. The polar height of the pyramid is 15 centimeters. So from here to the center of the pyramid is the height, which is 15 centimeters, meaning that from here to here it should to be 5 centimeters because this height goes to the center. Then remember we have a slight height here that we usually have to use for the surface area. This height works for the volume. That's what you have to call. They say the volume of a pyramid is 1/3 of the base times perpendicular height. That's the height. Total surface area of the base sum of the rectangular faces. That's it. Calculate the volume of the pyramid. The volume of the pyramid is just 1/3 because it's a pyramid. 1/3 area of the base, which is side squared times height. So which is 1/3, 10 squared, and the height is 15. So that is 1/3 times 10 squared times 15, which this gives us 500 centimeter cubes because that is in centimeters. Calculate the surface area of the pyramid. Surface area, we look at what do we see? We see a square. How many squares? We have one square, which is side squared, plus how many triangles? We have 4 triangles, but for the surface area, we use the slant height. So we must get the slant height first. So slant height squared is equals to the height inside squared, plus we can just say the radius, which is height is 15 squared plus 5 squared. So we have 15 squared plus 5 squared. 5 squared, which is 250. Is 250. So we do the square root of it. So we do the square root of 250, which this gives us 5√10. So that's the slant height. So we're gonna say it's 4 sides of the triangle. 1/2 times the base, which is 10, times the slant height, which is 5√10. So what is the side? The side is 10 squared plus 4 into 1/2 into 10 into 5√10. So now which we're going to have is 10 squared plus 4 into 1/2 10 times 5/10. So that will give us 416.2 centimeters squared. So that's how we do that. Let's go to 6.2. This a child is given some little clay to play with. At first, he uses all the clay to make a single sphere ball. Thereafter, he uses all the clay to make identical small sphere. If the diameter of each of the smaller sphere is exactly half the diameter of the original sphere, how many small spheres will they be able to make? So what do we do in this case? So let's make the diameter of a sphere. Diameter of a sphere bx. So now that means that we're going to use the volume of a sphere, which is 4/3 r squared. So if the diameter is x, therefore the radius is x. It's good. The radius is x/2 cubed. So which in this case we're going to have a 4/3 pi x cubed over 8, which this multiplies here. So it's 4/3 times 1/8. So that we just get the side of this is 1/6 pi x cubed. So fine, that's it. So they say that's the volume. This is the volume of the clay. Let's check now. They said now if the diameter of each of the smaller sphere is exactly half of the diameter, so that means that the diameter of the smaller sphere, it is equal to the radius of the bigger sphere because of the original sphere of the bigger sphere. So that means that this x/2 it is equal to d. Then we divide it by 2. Then now we have x is equals to 1/2 divided by 2, which is, that means that is x/4 is the radius of the smaller sphere. So volume it is equals to 1/4 supposed to 4 over 3 pi r cubed. So in this case, it's 4 over 3 pi into x over 4 cubed. So now we are going to just work on that. The cubed, which is 64, so it's 4 over 3 pi x over 64. So it's 4 over 3 times 1 over 64. Just working with the numbers, it's 1 over. Is going to be, the volume is going to be 1 over 48 pi x cubed. So volume over volume, so the volume is 1 over 6 pi r cubed is to 1 over 48 pi r squared. So if we divide here by 1 over 6, 1 over 6, so we're going to 1 over 6 pi r cubed, we just want to check the ratio, it's 1 is to it's 1 is to 8, so we can make 8 spheres. So we can make 8 spheres. That's how we can answer 6.2.